So in this video, we want to look at running a least squares adjustment on the data using all the redundant observations that we have from RTK and total stations. This we're going to cover at a fairly basic level, and the intention is to put up another video that goes through it in much more depth at a later stage. So before we do any least square adjustment on this data, it's very important that we get our initial error estimates for the observations correctly set. So we need to consider things like, was a pogo being used? Was a traverse kit being used? We need to get the error estimates for our observations correctly set. So these are what we call the a priori errors. So we go up to our cog at the top for our project settings. We go to default standard errors. And by default, we can import the data or the errors from how they've been set up in Trimble Access. So you can go into Trimble Access in your survey styles, and you can configure your initial error estimates. A lot of people don't use them, so I would suggest for our centering errors, we use our project settings. And then for our standard errors, we might want to use the imported files. So I would suggest that we do use the imported files. The reason for that is that TBC will actually read the data from the Trimble Access job file. So if a 5-second S6 has been used, a 1-second S8, a 1-second SX10 has been used, then it will automatically use that as the initial accuracy estimate for the angle. Unless, of course, rounds of angles have been used. If rounds of angles have been used within Trimble Access, then Trimble Business Center will use the standard deviation of the rounds as the initial error estimate. But the ones that we're changing mostly are our centering errors. So if we choose project settings, then when we go into our total station, we can put accurate or reasonable centering errors for our observations. So here, because pogos have been used, then it seems reasonable to use something like a 5mm centering error and a 5mm error in height of target. Obviously, if a traverse kit had been used, then we would expect to have something much tighter. Maybe 1mm in each parameter would seem reasonable. If we go to GNSS though, then I know the RTK observations have been done with a pogo, so therefore it's certainly unreasonable to use a 1mm centering error. So we can go in there and say 5mm. And then for the error in the height of the antenna, there's probably a little bit of wear in the pole, so let's just say we can be up to 5mm in the height of the pole. And then we can just click OK. For the initial error estimates for the GNSS data, if we've got it set here to imported files, then it will automatically read the covariance matrix that's imported as part of the GNSS data with Trimble Access. So it will weight it accordingly. So if you've got precisions of 20 mil for your observations, then that's how it will be weighted. So if we use imported files, then the GNSS data will be weighted based on the precisions of each observation. So when we've got our initial error estimates sorted out, then we need to look at our fixed point. And in this case, which is often the case in the UK, then we will have a VRS station. And you can see that this VRS station is PRS. So what we can do is we can go into our Project Explorer and we can go and find this. So we go to our Points tab in the Project Explorer, and we're looking for any attached coordinates, and it will come through as default as a survey accuracy point. And we want to move that up to a control quality observation. So it's very important that we fix any known points. And typically in the UK, when we're doing a normal topo survey, our only fixed point will be our GNSS base station that comes fundamentally from OSNet. Once we've got that fixed and we've got our a priori settings correct, correctly set, we can go to survey and we can just say adjust the network. I'm going to fix it and run the adjustment. And we can see that fairly, certainly not without surprise, is that our weighting is not quite correct. So if we run the adjustment, we look at our weighting, and we can see that the one that differs mostly from one is the vertical angles. And that's very common, that our vertical angles are not quite as good as we wish for them to be. It could be coming that our accuracy in the measurements of our height are not quite as good as we hoped. So we might want to go back here and go to our total station observations and actually say, well, I don't think these are quite as good as we hoped. And maybe we can only measure them to 2 mil. And if we run the adjustment based on these new error estimates, then we'll probably see our vertical angles drop down quite a bit here. So we'll just let that run through. And you can see here that they're, as we had expected, they're dropping down. But they're still not quite as good as we hoped. Generally, the strategy would be that we look at the values that differ from 1 by the greatest amount, and then we apply a weighting. So essentially here we're down weighting. Because this is much greater than 1, we're down weighting our initial error estimates for the vertical angles. Run that through, let it update, and we should see under results it's still failing. Next thing we do here generally is that we'd focus on the next one that differs from 1 by the greatest amount. Normally this would be the RTK values, but it looks like we've got the RTK values pretty well weighted here. So here we're actually going to apply a weighting to our horizontal angles. This would probably tend to indicate to me that our centering's not been quite as good as we'd hoped, rather than the actual horizontal angles themselves are less accurate. So we apply that, and then finally we're going to apply the slope distances. And then if I want to get it correctly weighted, then I'm going to, it's very rare you'd actually be applying a weighting to your RTK values last, but we're actually upweighting those. We're giving them a heavier weighting. They're going to have more influence on the data. So we've got things nicely, the errors estimates well balanced now. We go to our results and we see that things are passed. If we click on any observation, then we will see the precision estimates for these, or error estimates for these stations in turn. One of the things that I really like about this particular interface, if I click on an observation, then it shows me the residual on that observation. So basically the residual would be the difference between the final coordinate and the observation in its initial position. So how far has this coordinate been, how far is it different from where it was at the start from the RTK value. So it just lets us get a good feeling for the data, and we can do the same with our total station observations. And we can see that things are still relatively fitting pretty well. If I look back at my flags window here, I can still see there's a couple of flags which are telling me that our residuals and our mean turned angles are still higher than we had set for our tolerance. And these values are not without surprise here. So 12 seconds for a round of angles, it's higher than we expect, but it's not shocking. And then 4 seconds. We could dig in here and look for outliers within the rounds of angles if we wanted to, but notice after the adjustment has been applied, all my other flags have disappeared. So the fact there was actually observations going into station 4 that differed was actually all down to the fact that they were sitting on fixed points on the RTK data, which when we actually distribute the errors, everything's fitting very well as a combined data set. So once we've done our least squares adjustment, we could of course choose to apply our digital level data or our dumpy level data, but we can do our least squares adjustment report, which we're not going to cover in detail in this session, but we can have a dig through that, look for, we've seen there's no residuals anyway, there's no outliers anyway, but we could have a perusal in depth through that report if we want to. But generally now we're at the stage where we can hit OK and we can finish with that adjustment there. So the next video will go through a little bit about the Bowditch adjustment that can be used inside TBC.